Hi friends, are you ready to learn about angles and their units? You know that angles are measured in degrees. But did you know there is another unit called radians that is also used to measure angles? Now what is this radian unit and how do we convert from degrees to radians? Don't worry, I'll be covering all these concepts in this video and I'll be explaining it to you with simple and practical examples. So definitely watch the video till the end. But before we begin, I just want to let you know that we have full courses on our website manochaacademy.com and our Android app. To make it easy, I'll put the links below. So alright, ready? Let's go ahead and get started. First of all, what exactly is an angle? Angle is a measure of rotation. Now if I rotate the line, this is the angle formed. This is a 60-degree angle formed here. Now if I increase the angle, this is a 90-degree angle. Now this is a 120-degree angle. When we form a straight line like this, it is a 180 degrees angle. Now you keep turning it and the angle now is 270 degrees. And when you give it a full rotation, you get a 360-degree angle. We can define an angle as a measure of rotation of a given ray about its initial point. The original ray is called the initial side and the final position of the ray after rotation is called the terminal side of the angle. The point of rotation is called the vertex. The measure of an angle is the amount of rotation performed to go from the initial side to the terminal side. Now let's talk about clockwise and anti-clockwise rotation. From the initial side, if I rotate the angle in an anti-clockwise way like this, then the angle formed is positive and we can denote it as theta. But rotation can be done like this in a clockwise manner as well. Then the angle formed is negative and we can denote it as minus theta. If you don't do any rotation, then what is the angle formed here? That's right, 0 degrees because there is no rotation. Now if you do a full rotation like this, what is the angle formed? Even though the terminal side and the initial side match, but we did a full rotation. So the angle is going to be 360 degrees. The full 360 degrees can be divided into 360 equal parts. So 1 degree is 1 by 360th part of a full revolution. So every time you move 1 degree, you move a very small, a tiny angle. And when you move 360 times like this, then it is the full 360 degrees, or we say we have done a full rotation. You can also take the example of a cake. So let's say you take your birthday cake and cut it into 360 equal slices. So each of this slice is going to represent 1 degree, an angle of 1 degree. If I make a rotation like this, how much is the angle formed? That's right, it's 45 degrees. Now if I increase the angle now is 90 degrees. And if I increase the angle so that the two sides form a straight line, the angle is going to be 180 degrees. If we rotate it further like this, the angle here is more than 180 degrees. Let's say it is 200 degrees. Now if I start again from the initial point, but now I make a rotation like this. What is the angle now? That's right, it's minus 30 degrees since I made the rotation in the clockwise direction. And if I make a rotation like this, the angle is minus 90 degrees. And if we increase the angle further, the angle is now minus 120 degrees. So remember, we use the negative sign when there is a clockwise rotation. And when it's anti-clockwise rotation, the angle is positive. There is another unit we use to measure angles, and that's radians. Radians are a bit different. To measure the angle in radians, first you measure the length of the arc formed. Now when you divide the length of the arc formed by the radius of the circle, you get the angle in radians. So angle in radians equals the length of the arc divided by the radius. So we can denote it as theta equal to L divided by R. Now greater the angle, the length of the arc will be more, and as you keep increasing the angle, the length of the arc will also increase. That is why radians unit is based on the length of the arc formed. Now coming back to an acute angle like this, remember radians is going to be the ratio of the length of the arc by the radius of the circle. So the formula is theta equal to L by R. Very important formula, you need to remember this. Now let's go a bit deeper into the radian concept using two angles. Here I have two angles formed with a different radius. Let's say the radius of the black angle is 5 centimeters and the radius of the white angle is 10 centimeters. Let's measure the length of the black arc and let's say it turns out to be 5 centimeters and the length of the white arc is 10 centimeters. Now if you measure the ratio of the arc length divided by the radius for the two angles, what do you get? L by R for the black angle is going to be 5 centimeters divided by 5 centimeters. So that's 1 radian. And the L by R for the white angle is 10 centimeters by 10 centimeters. So that's also 1 radian. So both are the same here since we have identical angles. We have taken identical angles. So the arc length by radius ratio will be the same in this case. So remember, an angle of 1 radian is formed when the arc length is equal to the radius of the circle. So similarly, when we make a 90-degree angle for both of these, once again the arc length by radius ratio will turn out to be same because both the angles are same. And if you increase the angle to 180 degrees and form this semicircle arc, once again the L by R ratio for the black angle and the white angle is going to be the same. How do we convert from degrees to radians? Let me show you in a very simple way. If we start like this and give it a rotation to form a straight line, what is the angle formed here in degrees? This is 180 degrees. But how much is the angle in radians? For radians, remember the formula is theta equal to L divided by R. Now what is the length of the arc formed here? So what is L? The arc is a semicircle. So we can use the circumference of the circle formula. Circumference of a circle is 2 pi r. But here the arc is semicircle, half of a circle. So its length will be circumference divided by 2, which equals pi r. So the angle in radians theta is going to be pi r divided by r, where r is the radius. So that is equal to pi radians. So now you can easily remember with this example that 180 degrees is equal to pi radians. So that is the conversion from degrees to radians. Another way to remember the conversion is to complete the full rotation of the angle. The full rotation is 360 degrees. And what is the corresponding angle in radians? Once again, you can use the formula theta equal to L divided by R. Arc length divided by the radius. Arc length is the circumference of the full circle. So that's 2 pi r. And when you divide it by the radius r, the r will get cancelled. So the angle is 2 pi radians. So the conversion is 360 degrees is equal to 2 pi radians. So you can remember the conversion as 180 degrees equal to pi radians or 360 degrees equal to 2 pi radians, whichever one is convenient for you. And then if you apply the unitary method, you will get 1 degree equals pi divided by 180 radians. So if you want to convert from degrees to radians, just multiply by pi by 180 and you will get the answer in radians. And if you want to do the reverse, you want to convert from radians to degrees, just multiply by 180 by pi and you will get the answer in degrees. As simple as that. Now let's look at the degree to radian conversion for the standard angles. If we convert the angle 30 degrees to radians, we are going to get pi by 6 radians. You can use the formula that we learned, 30 multiplied by pi by 180. So that is the conversion, right? You multiply by pi by 180, so you will get pi by 6 radians. Now that you know how to convert from degrees to radians, let's take a look at the table for the standard angles. So for example, 30 degrees is pi by 6 radians. 45 degrees is pi by 4 radians. 60 degree is pi by 3 radians. 90 degree is going to be pi by 2 radians. 180 degree, the semicircle, is going to be pi radians. Remember, that was a conversion. 180 degree is pi radians. And then 270 degree is 3 pi by 2 radians. And if you complete the full circle, that is 360 degrees, it's going to be 2 pi radians. If you forget this, you can quickly convert it also, but I recommend that you should know these values. That way you can do your sums much faster. So make sure you learn this important table for the standard angles. Now let's try out some questions related to degrees and radians. Here's the first question. You need to convert 100 degrees into radian measure. So how will you do this? One simple technique is that 180 degrees is pi radians. So you can just simply apply unitary method here. We know that 1 degree is going to be pi by 180 radians. And so 100 degrees is going to be pi by 180 times 100 radians. So if you simplify this, 0, 0 gets cancelled and we are left with, this will be 2 5s are 10 and 2 9s are 18. So we are left with 5 pi by 9 radian. So this is the value expressed in terms of pi, but if you want to convert it into a real decimal, if you want to calculate in terms of decimals, then you should substitute the value of pi. Remember, pi is an irrational number, that 3.14159 and so on, dot dot dot, but you can use the approximate value of 22 by 7. That is usually convenient to do. So if you substitute pi as 22 by 7, you will get 5 by 9 times 22 by 7, which is 110 degrees divided by 63. So if you do this division, you will get 1.745 radian, and if you want to round it off to 2 decimal places, since it is 5 here in the third digit, so we will add 1 to the previous digit. So this final answer will be 1.75 radians. So 100 degrees is approximately 1.75 radians for you. Now you can do unitary method, but you don't have to do this every time. It's better to just remember the conversion directly, that if we are going from degrees to radians, you need to multiply by pi by 180. So you can directly do this. You can say, so the direct method will be 100 degrees, directly you multiply by pi by 180. So that is your conversion. So many radians, and then from there you will get the same thing. 0 and this will cancel, so you'll get 5 pi by 9 radian, and if you do the division, you will get 1.75 radian. So no need to use the unitary method every time. Directly multiply by pi by 180 to go to radians, and if you're going from radians to degrees, then you need to multiply by the reciprocal, 180 by pi. As simple as that. Let's try another question. This time we need to convert 40 degree, and what is this symbol? This is for minutes. So 40 degree 20 minutes into radian measure. And remember, 60 minutes make a degree, just like 60 seconds make a minute. So these are sub units of the degree measure. So let's see, how do we do this? 40 degree 20 minutes. So the first thing I need to do is I need to convert the minutes to degrees. So what is it going to be? 40 degrees and 20 divided by 60, because 60 minutes make 1 degree. So this is basically 41/3 of a degree. Now you need to convert this into radians, and remember the shortcut trick, multiply by pi by 180. But before that, let's convert this into a mixed fraction. So let's convert this into a mixed fraction. So denominator is going to be 3. 40 times 3 is 120 plus 1. So I'm getting 121 by 3 degrees, and we need to convert this into radians. So when we convert to radian, we can say the radian measure will be 121 by 3 multiplied by pi by 180. So what is the answer going to be, guys? It's going to be 121 pi by 540 radians, or I'll write just rad in short. That is our final answer over here. Now once again, you can convert it to a decimal if you want. So if you substitute pi as 22 by 7, You can find the final answer in decimal also, but you can leave it like this if it's not needed. So simple. Here's the next question. This one is more interesting because we have a negative sign here. So what do? Remember what is the meaning of a negative angle? That your angle is downwards, right? It is drawn downwards like this. This is your minus 47 degrees and 30 minutes. Once again, we need to convert the minutes to degrees. What is the conversion? We know that 60 minutes is 1 degree. So 30 minutes is going to be half a degree, right? So what is this angle that we've been given here? It is minus 47.5 degrees. And keep the negative sign because it indicates that the angle is downwards over here as shown. So now we need to convert this into radians. Very simple. Once again, multiply with pi by 180. Before doing that, make sure you convert this into a mixed fraction. So what is it going to be? This is minus, and if you put 2 in the denominator, 47 times 2 is 94 plus 1. So that is minus 95 by 2 degrees. And we need to convert this guy into radians. So all we need to do is multiply by pi by 180. So keep the minus sign, 95 by minus 95 by 2 degrees times pi by 180 radians. And don't leave the answer like this. Make sure you simplify the fraction, otherwise your maths teacher won't like it. So let's do that here. And we can see that with 5 this will cancel. So we are going to get a minus 19 on top. So 19 5s are, and this will, you'll get a 36 here. So the final answer is going to be minus 19 pi by 72 radian. I'll write RAD in short. There you go. That's our answer. And remember to keep the negative sign because this means we are going in the clockwise direction. We are going downwards in the clockwise direction. Negative sign means clockwise. Positive sign means you're making the angle anti-clockwise. Now let's try a question where we need to convert radians into degrees. The question is, find the degree measure of 11 by 16 radian and the pi value is given to you as 22 by 7. When the pi value is given, that means you need to use it and substitute and find the final answer, not leave it in terms of pi. So how do we do this? Remember, pi radians is 180 degrees. So if you go by unitary method, 1 radian is 180 divided by pi degrees. So once again, you don't have to do the unitary method every time. The trick is to convert from radians to degrees, you need to multiply by 180 by pi, right? Degree to radian, pi by 180, and radians to degrees multiplied by 180 by pi. So let's go ahead and do that because we've been asked to convert 11 by 16 radian. So 11 by 16 radian, how much is it going to be? Very simple. We'll just multiply 11 by 16 times 180 by pi. So this step is simple. Now you should do your calculations. So substitute pi as 22 by 7. So 11 by 16 times 180. My pi value I will put down as 22 divided by 7, which means the 7 goes on top. So now let's simplify this stuff. 11 and 22. So we are left with 2 here. And then let's see if we can do some more cancellation. If we divide with 4, I think 4 16s are, and this is divisible by 4. 4 4s are 16, and we are left with a 45 here, right? So finally, what are we getting? 45 times 7 divided by 8, which is 315 degrees. So 315 by 8 degrees. Now, if you convert that to a mixed fraction, what will you get? So we shouldn't leave the answer like this, right? We should convert it into a mixed fraction, and you will get, if you divide that 315 by 8, you're going to get 39 3 by 8 degrees. But better not to leave the answer like a mixed fraction like this in terms of 3 by 8 degree. We should convert it into minutes and seconds, because remember 60 minutes is 1 degree. So let's do that. So how will you do this? So the 39 degree, you'll keep it here, and 3 by 8 we will multiply with 60. So when you simplify that, what are we getting? This will cancel with 4, and this is 15. So I'm getting 45 by 2 minutes, which is 39 degrees and 22.5 minutes. Again, let's not leave that half there because we should convert it to seconds. So this will be 39 degrees, 22 minutes, and half minute is how many seconds? 30 seconds, because half times 60. So it is going to be 30 seconds here. So this is the final answer, and I recommend you write it like this in terms of degrees, minutes and seconds, and not leave it like this mixed fraction here. So here we have converted the radians to degrees, and these are the steps that you should use. Here's the next question. Find the degree measure of -4 radian. Remember, -4 means you're going clockwise when you're making the angle. So our job is to convert this into degrees, so we will not care about it and just keep the sign. We don't care about clockwise, anti-clockwise right now. So -4 radian, I need to convert it into how many degrees? And what is the shortcut trick? Simply multiply by 180 by pi. So when you're going from radians to degrees, so -4 radians is going to be -4 times 180 by pi degrees. And they've asked you to take pi as 22 by 7. So let's substitute it here. What will we get? -4 times 180, and pi will be 22 by 7. So the 7 goes on top here. Now let's see if anything cancels. So I think we can cancel with a 2 here. So -4 times 90 times 7 divided by 11. If you guys do this multiplication, you will get -2250 divided by 11 degrees. Obviously, we can't leave the answer like this. So first change it to a mixed fraction and see if we need to convert it into minutes and seconds. So if you do this calculation, you're going to get -229 1 by 11 degrees. So this 1 by 11, we need to change it into minutes and seconds. So this is easy to do because this is nothing but -229 degrees and plus 1 by 11th, I'm going to convert it into minutes by multiplying by 60, right? So if you simplify this, what will you get? -229 degrees, 5 minutes, and then you have another 5 by 11 here, which will convert it into seconds. So you can say plus 5 by 11 times 60 to convert it into seconds. So if you do this conversion, you will get -229 degrees, 5 minutes, and 27 seconds approximately, if you do that division of 30 by 11. So this is the final approximate answer. So there you go, we have converted radians to degrees. Don't forget to put the negative sign, which indicates it is a angle drawn in the clockwise direction, and also remember to convert to minutes and seconds. So very easy, just use this shortcut trick of multiplying by 180 by pi. Do your calculations carefully, and I'm sure you'll find these degree radian conversions really simple. And now for an interesting homework question for you. Here's the question. If in two circles, arc of the same length, subtend angles of 60 degree and 75 degrees at the center, as I've shown here in the two figures, you need to find the ratio of their radii. That means the ratio of the radii of the two circles. Again, if the diagram is not given, you must draw a rough diagram to visualize the question. So you need to find the ratio of the radius R1 is to R2. And let me give you a hint. Again, remember the important formula we have done, the way radians is defined, theta equal to L by R. And don't forget that this angle must be in radians, not in degrees. So see if you can use this formula and find the ratio of the two radii. So do try out this homework question and let me know your answers by putting it in the comments below. And I promise to reply to your answers. So go ahead and try this homework question and put your answers in the comments below. Friends, I hope the concept of radians is super clear to you now. You might be wondering, why do we need radians when we already have degrees? Well, radians are incredibly useful in advanced mathematics and science, especially in calculus and trigonometry. They simplify many mathematical formulas, making them more elegant and easier to work with. And if you like this video, don't forget to hit the like button and share it out with your friends. And if you haven't subscribed to our YouTube channel, come on, smash that subscribe button right now and click on the notification bell so that you don't miss out on any of our videos. And do check out the full courses on our website manochaacademy.com and our Android app Manocha Academy. I'll put the links below. Now what will you get in our courses? In our courses, you're going to get live classes, interactive videos, quizzes, questions, mock tests and revision notes. So they're going to be really useful for your exam preparation. So do take a look. I'll put the links below, and we have various courses for you like physics, chemistry, biology, maths, coding and artificial intelligence. So do share it out with your friends and stay connected with us and just keep on learning.